Okay, so here it has been asked to minimize and maximize the objective function, which is z. So here the objective function is z is 5x plus 10y, 5x plus 10y, and the linear constraints are x plus 2y is less than or equal to 120, and x plus y is greater than or equal to 60, and x minus 2y is greater than or equal to 0, and x comma y will be greater than or equal to 0. So this represents the first quadrant. This represents the first quadrant. So now here first we should draw the approximate graphs of the straight lines, which are x plus 2y equals to 120. So this will intersect on the x-axis at the point 120, 0, and on the y-axis at the point 0, 60. So these are the 2 points on this straight line. And x plus y equals to 60. For this straight line, the points are 60, 0 and 0, 60. And for x minus 2y equals to 0, it will pass through the origin 0, 0, and it will also pass through the point, suppose if I put x equal to 60, then y will be 30. So from the point 60, 30 also it will pass. So we can draw the approximate graphs of these straight lines. So let's suppose this is the y-axis and this is the x-axis. So here you can take 3 points, 30, 60 and 120. Here also I can take 30, 60 and 120. Suppose here this is 30, 0. This is 60, 0. This is 120, 0. And this is 0, 30. This is 0, 60. And this is 0, 120. So x plus 2y will pass through the points 120, 0 and 0, 60. So we should join these 2 points. So this is the approximate straight line, which is x plus 2y equals to 120. And this straight line will pass through 0, 60 and 60, 0. So it will be somewhat like this. It is x plus y equals to 60. And this will pass through 60, 30. So 60, 30 will be somewhere here. So 60, 30 will satisfy this line also. 60, 30 will satisfy this line also, since 60 plus 60 is 120. So it will lie on this straight line. Actually, this is 60, 30. So this is x minus 2y equal to 0. So now we have to find the coordinates of the corner points, which are A, B, C, and D. Here, actually, first we need to see that this inequality satisfies the origin. Origin will satisfy this inequality. So therefore, here the shape is somewhat like this. We can draw one rough diagram of this graph here also. So it is somewhat like this. So for x plus 2y equal to this this is the region which contains the origin. So it means it will be this region. And for this straight line, 0, 0 will not satisfy. 0, 0 will not satisfy. This will satisfy the origin. And so it means this should lie away from the origin, means this part and this region. And for this straight line, for this inequality, 60, 30, we have to check 60, 30. Yeah, 60, 30 will satisfy it. So it will contain the region, this region. So the intersection of these three regions will be this region, this region. So this region is the required feasible region. So therefore here the region ABCD is the required feasible region. The required feasible region. And this region, it is a bounded feasible region. It is a bounded feasible region. Since it can be enclosed within a circle, I can enclose this feasible region within a circle. So it is called as a bounded feasible region. So we need to find the corner points. So the corner point A can be obtained by solving the straight lines, this one and this one. So if we solve it, x minus 2y equal to 0, and you have to solve x plus 2y equals to 120. So here x equal to 2y. So if we put that, then we will get 4y equals to 120. So y will be equal to 30. Then x will be equal to 60. So the point A is obviously 60, 30. And the point B, how to find? Point B is the point of intersection of this straight line and this straight line. So x minus 2y equal to 0, and we need to solve x plus y equal to 60. So here x is equal to 2y. So if we put that, we will get 3y equals to 60. So y equal to 20. Then x will be equal to 40. Therefore, this point B is 40, 40, 20. Point B is 40, 20. And then the point C, point C is 60, 0. Point D is 120, 0. So we know that the maximum value of this objective function and the minimum value of the objective function should occur at the corner points of the feasible region if it is bounded. So therefore, here we need to make one list, which is the corner point. Here we can write the corner point, and here we can write the value of the objective function. Value of the objective function at the corner point, which is z, which is equal to 5x plus 10y, 5x plus 10y. Okay. So for the corner point A, which is 60, 30, and the point B is 40, 20. Point C is the point C is 60, 0, and the point D is 120, 0. Okay, so therefore the value of z here, it will be 5 into 60 plus 10 into 30. So it is 300 plus 300, it is 600. And the value of z here, it is it will be 5 into 40 plus 10 into 20. So 200 plus 200, so it is 400. And the value of z here, it is 5 into 60 plus 10 into 0. So it is 300. And here z is equal to 5 into 120 plus 10 into 0. So it is 600. So at both these corner points A and D, the value of the objective function z is coming same. Therefore, at all the points joining the line segment AD, the value of z will be the same. It is the rule. So A and D. So therefore, I will tell, therefore, the maximum value of z is 600, which occurs at all the points joining the line segment AD, where the point A is 60, 30, and the point B is the point D, which is 120, 0. So at all the points on the line segment AD, the value of z will be the same, and the minimum value of z, the minimum value of the objective function, will occur at 60, 0 at the point C. Okay, and the minimum value of the objective function is 300, which occurs at the point C, which is 60, 0. So this is the final answer. Thank you.